Hello there. Thank you for revisiting the King's Academy, your knowledge channel. Please watch till the end, and we love to hear your feedback. Let us now jump into the video.
Imagine the most densely populated, bustling skyscraper in the entire forest. Now, what if I told you this skyscraper, well, isn't even alive?
That is quite the hook.
Right. Welcome to this deep dive into the fascinating article, Skyscrapers of the Forest, the hidden life of dead trees. Our mission today is to figure out how decaying wood, something we usually just ignore, is actually the secret beating heart of the forest.
Yeah, and for the skeptic in you listening right now, you might look at a dead tree and see, well, a hazard.
Like an ugly, rotting log that just needs to be chopped down.
Exactly, clear it out. But the data shows something completely counterintuitive. A standing dead tree, which ecologists call a wildlife tree, is frequently more biodiverse than it ever was when it was alive.
Wait, more biodiverse. Let's unpack this, because I'm honestly struggling with the basic physics here. If a live tree is essentially a giant solar panel generating energy for the forest, how does a dead piece of wood support, more life? Where is the baseline fuel coming from?
That is the crucial mechanism here. The energy isn't gone, it's just locked up in the physical structure of the wood itself.
Oh, gotcha.
Yeah, specifically in complex polymers like lignin and cellulose. When a tree dies, its active biological defenses drop. That allows microscopic fungi and bacteria to invade.
So they're softening up the wood, like they're prepping the construction site for the next phase.
Yes. As those mechanical properties change, the wood goes from being rigid armor to a pliable medium. That structural change is what allows cavity nesting birds like woodpeckers, owls, and chickadees to physically excavate homes right into the trunk.
Which basically turns this dead husk into a multi-story apartment complex.
It really does.
And the forest real estate market moves fast, right? Once a woodpecker moves out, that hole doesn't just sit empty. Secondary tenants like squirrels, bats, or raccoons move right in.
Yeah, it provides essential shelter on a massive scale, going all the way from the canopy down to the root system.
Quick pause right here. Make sure you stick with us until the very end of this deep dive, because the visual transformation of these dead trees will completely change how you see the forest.
Oh, absolutely. It's stunning.
But before we get to the aesthetics, an apartment complex is useless if the tenants starve. Why are so many different animals concentrating around one dead piece of wood?
Well, the birds and mammals are moving in precisely because the walls of their apartments are quite literally filled with food. Those fungi breaking down the wood attract massive populations of beetles and larvae.
Oh, I see.
Yeah, the insects tunnel through the softened tissue to consume that newly unlocked energy.
Ah, the domino effect. You have this localized explosion of insect life, which naturally draws in the insect-eating birds and small mammals looking for an easy meal.
And the cascade continues outward. That high density of small prey turns the base of the dead tree into a prime hunting ground. Apex predators, like hawks, owls, and larger carnivores, they start patrolling the area.
So the biological breakdown of one single tree fuels this highly concentrated vertical food web. It makes you realize how hyper-efficient nature is.
Totally.
But it isn't just a purely utilitarian food chain. The physical process of all this decay actually creates what our source describes as a natural art gallery.
The visual evolution is strikingly beautiful. We are conditioned to associate decay with ruin, but a wildlife tree develops an incredibly unique aesthetic.
Yeah, as the bark peels back, it reveals those intricate maze-like galleries left behind by the wood-boring insects.
And then you get those vibrant, almost neon hues from the mosses and lichens colonizing the softened surface.
It's like every hollow, every scar, and every patch of moss is mapping out the tree's history long after the sap stopped flowing.
Right, and no two dead trees will ever look the same because the biological sequence of who moves in and what eats what is entirely unique every time. The process of decomposition paints a different picture on every single trunk.
So, to close that open loop we started with, that bustling, invisible forest metropolis isn't some ghost of the past. It is the dead tree, actively anchoring the present landscape.
Since this deep dive is always tailored specifically for you, I want to thank you for your time today. Whenever you are ready to have more knowledge synthesized, we formally request that you revisit King's Academy in the future.
Absolutely. And please let us know your opinion in the comments section below. As always, we read all posted comments and will reply to you as soon as possible.
I will leave you with one final thought to mull over. If a tree provides significantly more diverse life and intricate beauty after it dies than it ever did while alive, how might that change our modern human obsession with constantly clearing away the old to make room for the new?